Myself, Dr. Abid Naimuddin, working as Associate Professor in the Department of Electrical and Electronics Engineering and convener of this FDP. Honorable Chairman of G. Pullaredi Engineering College, Autonomous Kurnool, Sri P. Subbareddy Garu, respected Principal Dr. B. Srinivas Reddy Garu, Head of the Triple E Department Dr. K. Sri Gauri Madam, Head of the ECS Department Dr. R. Praveen Sam Garu, Head of the EC Department Dr. S. Nagaraj Rao Garu, eminent faculty members, dear participants, good, good evening to all of you. It gives me a great pleasure to welcome to all the participants to the Day 4 session of this 1 week international level faculty development program on Introduction to Artificial Intelligence during 9th to 14th October 2023, organized by the Department of Electrical and Electronics Engineering in association with NI LabVIEW Academy of GPREC, Department of Emerging Technologies in Computer Science and Department of EC. I am very happy to share that we got tremendous response from the participants. A total number of 1,1872 participants has been registered for this workshop. I am happy to share that the participants are from Kashmir to Kanyakumari, covering 23 states of India. Not only India, the participants are also from Dubai, Kingdom of Saudi Arabia, United States of America, and Australia. Now, I request Wajiha Mehek, a fourth Tripoli, to introduce today's speaker.
Thank you, sir. Good evening to one and all. I, Wajiha Mehek of Fort Tripoli, take it a privilege to introduce today's speaker, Mr. M.K. Pavan Kumar. Mr. M.K. Pavan Kumar is currently working as Data Science Manager at SquadStack. Mr. M.K. Pavan Kumar is highly accomplished applications architect and data scientist working for Honeywell Technologies with over 13 years of experience in the industry. He has proven track record of leading successful software development projects from concept on to launch with a keen eye for detail and commitment to delivering high quality products. Throughout his career, Mr. M.K. Pavan Kumar has built and managed large complex software systems in various domains like finance, ERP, aerospace, and SCM. He is also an expert in software architecture and data science, having designed and developed complex systems that are scalable, maintainable, and efficient. Mr. M.K. Pavan Kumar holds a dual master's degree from BITS Pilani and Usmania University, Hyderabad. Prior to his current role as applications architect and data scientist, he worked for Nest Technologies as technical lead, held a variety of technical positions, including software engineer and tech lead. Our speaker's dedication has not only enriched his own career, but has also positively impacted countless individuals and communities. His commitment to excellence and his ability to communicate complex ideas in an engaging and accessible manner make him an ideal choice to lead and to today's session. On behalf of Jibularity Engineering College, I would like to thank today's speaker, Mr. M.K. Pavan Kumar sir, for dedicating his valuable time with us. Thank you, everyone. Now, I request Dr. Abid Naimuddin sir, convener of FDP, to take over the session.
Thank you very much, Wajiha Mehek. Now I request all the participants to utilize this opportunity and get benefit from today's session. And also I request all the participants to stay online and use YouTube live chat box for any queries for the smooth conduction of the workshop. The feedback link will be shared at the end of the session in the YouTube live chat box window only. So kindly submit the feedback which will be considered for the attendance to provide the certificates. Now I request today's speaker Mr. M.K. Pawan Kumar, application architect and data scientist to Honeywell Technologies, to take over the session.
Thank you very much. I think like this is the longest intro that I had. Um, Thank you,
Thank you, sir.
Abid,
Thank you, sir. Thank you.
and thank you. I think Mehak, if I'm not wrong. So yeah, good evening, everyone. I think like Abid also said, like there are participants across the globe. So I wish good morning, good afternoon, and good evening. Okay, so without much wasting of the time, I think like you already got my intro, like what I'm doing and all. So in a one liner, basically I can tell you I'm a blend of application architect as well as a data scientist. So I handle applications starting from their inception from one end, and I deliver the applications to other end. So it involves both the infrastructure architectures, the UI that you actually see, and the behind part of that, which is data science, APIs, and then artificial intelligence. So I think like you already know, I would be the speaker for the next 3 days, like today, tomorrow, and day after tomorrow. That I think like Abid, am I right? Correct. So it is like
Yes, yes, yes.
okay. So the journey, or as a intro, I would be telling you we would be starting slowly with artificial intelligence and a branch of artificial intelligence or a subsector which is called machine learning. So we would be starting with machine learning, and most of the time we would be dealing practically. I don't believe in theory much, but in fact I believe in practice a lot. Okay, so we would be taking, and even in practice also, when we talk about practice of a theory that we learn, I don't go by the book or some basic examples. So most of the time when we read about machine learning online or some with some resources, we eventually start, or they eventually start with something called um, predicting of house prices or something like that. But we take a real use cases, real time use cases, which are like on the desk of corporate, and then we start solving them, and then I'll be showing you in that particular angle. Okay, so as I said, the theory would be very less, the practical would be lot. So I request all the students to focus and utilize the opportunity, and then ask as many questions that you have, and I'll try to answer most of them. Else I would actually take a gap, and then maybe like I'll know if at all I don't know it, and then maybe I'll post it to Abid, and Abid will actually cascade that to everyone who actually has that particular question. So this is from my end. So without much delay, let me start sharing my screen, and we'll start our session. Okay.
Yeah, I am stopping my screen. I'm going to stop my presentation. So now you can present.
Yeah,
And
just a second.
participants are requested to post the queries in the chat box. So our coordinators will be having an eye for your questions during the last 10 minutes of the session. We will read out to the resource person.
Just let me know what exactly you're seeing. Okay, I think you're not seeing the right screen, but just a second. Okay, just a sec. Now just let me know what exactly you're saying. If you're seeing my presentation, it is good.
Yes, practical machine learning. Can you make it full
Yeah,
screen?
yeah, sure, sure. Able to see that or
No,
no?
no,
No, right? Just a
no.
sec.
I think you need to share entire window.
Yeah, I shared the entire screen actually. Just
Then once again you open PPT.
yeah, one sec. Just a second.
Yeah, no problem.
Are you saying it now?
Yes, yes. Now it is okay.
Okay, good.
So we'll have
So
last 10 minutes as a for query session.
okay, no
Okay.
problem. So we'll go through a quick overview of what exactly we are going to see as a theory part, and then we'll straight away jump into the practical, where you get more knowledge on how do you actually solve these machine learning problems. That's the whole point, and that is the whole reason even our session is called practical machine learning. It's not a theory part. Okay. So basically, what is machine learning and what is the focus of it actually? So we as a humans, we learn it from a past experiences. Okay. So today you have some scenario, it is not your intelligence, it is basically a brain who is acting as an agent which knows something has happened in the past, and it is deriving some kind of a decision based on its past. Okay, so that is a human actually response to any given scenario in front of him. Just a second. Hello, Masood. Okay. Okay, sorry. So so that is how we do it, and very similar to that. And a computer also learns from data. Okay, so that means like you have a huge set of data, and then we give it to the computer, and then or basically an algorithm, and then that algorithm gets trained over this particular data, and finally you give a new set of data, it will start predicting, or it will start giving you some kind of a decision based on the learning that it has went through over the data that have given to. Okay, so basically what is the focus is learn a target function. That's what I was telling, right? So the algorithm the trains over the data, and finally it gives some kind of a target function, and that target function will start predicting or classifying some kind of a values, and then that's the basically we call it as an objective. Okay, that's the objective of my algorithm, and that is what I want to do. Example, if you take a biological science use case or a case study, where we are trying to have predict basically mm, a patient has got a rabies or not. Okay, so that is one best example based on different behaviors, different attributes that you observe in a patient, then we will say that okay, he's infected with the rabies or he's not infected with the rabies. So that is one kind of an example. So these kind of problem statements, basically we call it as a supervised learning or unsupervised learning. Okay, there are two different aspects of machine learning, which is called supervised learning and unsupervised learning. Supervised learning, basically most of the time, like 90% of the time, we actually deal with something called the regressions and classifications. Okay, even if you go into a deep learning also, it is like a supervised learning only, which is again one more subset level of machine learning. Deep learning is also a machine learning, but it is little fine grained, and we do different aspects over there, but that is also a supervised learning. So you give some kind of images there, high dimensional data, and then we train the models, and finally it will start identifying, okay, this is this kind of a person and the other one is the other kind of a person, and something like that. Okay, so regression and classification, which are like predominant way of algorithms, regression algorithms and classification algorithms are best suited under supervised learning. And unsupervised learning, basically what exactly it is, so you have a data, but you don't know what exactly that data is speaking about. So okay, let me give an example and drive this particular unsupervised learning. It is important to know what is unsupervised learning, but we are not going to learn it here. Okay, so example, I gave you whole set of attributes and behaviors of aircrafts. Okay, so I have aeroplane data, so a lot of aeroplanes and a lot of data. So what kind of engine, what is the tail structure, how is the wings blend, what is the nose what is the tire structure, what is the build quality, what is the avionics section, which is the cockpit section. So I have a lot of attributes, how much height it can fly, what is the drag force it can handle. So all of these things if I can give you as a data set, but I don't give you what kind of a make or a model, whether it is Airbus or Boeing. I don't give you that. I only give the attributes like this. So now as a problem solver, so you go through that, maybe you after maybe a week of study over the data, you will find some kind of a pattern. Okay, oh okay, I'm finding like row number 23 and row number 33 both are looking almost same. Maybe I will group them out. Okay, I'll separate them from a main data set and then I'll put it as a group. I'll separate them out, these two. Similarly, you will go through the remaining data set and then finally you will identify and you may make n number of groups out of it. So this is nothing but again you are classifying. Okay, this is a classification problem you made as a groups, which we call it as clusters. Okay, how did you do it? Because there is no labeled data. I did not tell you these are the labels. Okay, if you see the data in this particular pattern, that means this is the label for that. And if you see the label in another format, this is the label for it. Okay, I did not tell anything, but you yourself identified a pattern or a procedure, and then you actually identified or classified them into different groups. That is called unsupervised. And supervised, this is the exact opposite thing, and we already a little bit covered also. So you have labels which are nothing but a target. Okay, if you see example, if you take hibiscus, which is a flower, so I can tell, okay, my petal length and sepal length would be something like this after measuring. So any flower which is actually matching nearest to this could be an hibiscus, or any flower which is not matching or way out of these measurements may not be an hibiscus, it could be some other flower. So okay, so this is like I already gave you a data and points, and then there is a class which is a label associated with every data set or a data point. So this is called supervised and unsupervised. Okay, so now what exactly is this machine learning? How is the machine going to learn? So you already learned from the previous two slides, you can actually infer that. So we know there is a data set and you have a task. Okay, and there is a performance measure which we did not study in the previous two slides, but this is a new term that we are introducing in slide 3. Okay, so which is performance measure. So how best you are actually predicting or classifying or grouping. Okay, that is the measure. So we call it as some, there are a lot of measures, but for your easiness I'll tell you it is accuracy. Okay, so if your accuracy is too high, then your algorithm is too good. Okay, if your accuracy is little low, then there is always, I mean, like algorithm is telling you there is something else you have to do in order to improve my accuracy. Okay, that is the performance measure. So now the definition is, this is the basic machine learning definition which comes from a standard textbooks actually. Okay, so a computer system is set to learn from a data set to perform a particular task. After learning, the system performance on the task improves the measurement by m. Okay, so that means you have to improve your accuracy over a particular given task on a given data set. That is what is the machine learning. Okay, and now coming to this is the model like today's agenda. Basically we are going to see at classification and regression. Okay, I'm not going to go too deep into the theory because there is a lot of mathematics and in one day it is impossible to cover. Okay, so I'll show you a base high levels and then we'll go into a practical where you will understand more than what theory is. Okay, so we have a training set, basically a data set, a huge data set. We will split that into two sets. Basically one is training and one is the testing. We will not expose it to the algorithm because it is unknowns to the algorithm, and we will train it on the train set, and ultimately we will measure how best the algorithm is behaving over the test set. And the output of the algorithm, as we have seen, there is a hypothesis function or a target function. So that is your hypothesis. To this hypothesis function, okay, or an objective function, you can call it as an objective function also. Okay, and for which like you can pass a new set of data and it will start predicting your value. Simple example I'll give you. This is basically a linear regression. I think like in our standard 10, we studied about linear equations, in which like we learned about equation of a line, which is y equals to ax plus b, right? So that particular equation is nothing but your linear equation. At that time, we may not know that we are learning machine learning, okay, but that actually represents a machine learning. Okay, so basically you have an independent variable. Independent variable can be multiple in nature. We call it as multilinear regression. But if you have only one, we call it as single independent linear regression. And then you have you have a dependent variable, which is y, and based on your independent variable you can actually predict your y. Okay, so this is how you get it. Okay, so you have a training set, linear algorithm. This is all we saw it. So this is the shorthand notation of what exactly I was saying. This is basically from a standard textbooks. This is the representation, but this also we discussed. Your y equals to theta naught plus theta 1 x, or you can put theta naught theta 1 into any of your variables. Like I can say b plus ax. Okay, I can do anything, but this is most standard. Like whenever you go into internet and search, or any books you refer, this could be one of the standard notation that you see it. Okay, and now here what I have taken as an example is, most of the time you go to some kind of a jewelry shops or something like that. You may actually see, like, assume that you went to purchase diamond jewelry. Okay, as and when you increase the size, or the carat is basically the size of, or the purity of the diamonds, right? So if you start increasing them, okay, that means like you want more clarity of the diamond, or purity of the diamond, or more size of the diamond. Obviously you can expect there is an increase in price. This becomes your regression problem. Okay, so you have a data set of different diamonds, their cut, their depth, their height, all these things, their color also, and then all these things, and finally there is a price attached to that particular data. Similarly, you have assumed that you have researched, you went into different jewelry shops, and then you formulated one data set. Now you can easily train an algorithm, and that algorithm is so much capable that if you start giving it a new diamond data, it will automatically start predicting this could be the price of this particular diamond that you are going to purchase. That's the power. Okay, this is the most evident example that you can actually try. You can conduct one research, and then you can try this. Okay, so what exactly we are trying here? We have a hypothesis function, we have parameters, and ultimate goal is to predict the dependent variable, which is h theta of x, or simply h of x. Now the problem is, how do you find that theta naught and theta 1? Okay, so if you have these two, obviously I can find my dependent variable, that is h theta of x. But how do you find? Most of the time what we do is we choose random values of this theta naught and theta 1. Okay, so if you see this, I have my random values of theta naught theta 1 at different sections. Like one time it is 1.5, 0, 0, 0.5, 1, 1, 0.5, all those things. But out of this, what is the best theta naught and theta 1? How do you get it? The best depends on two things. One, the most accurate and nearer value of predicted value towards the actual value. Okay, that those values of theta naught and theta 1 are considered as the best. Now how do you know which is the most nearer value of the predicted value is nearer to the actual value? That is what we call as cost function. Okay, so cost function is basically your predicted value, your h theta of i's. So you have number of you have ample amount of data set, so every data point is considered as I. So I runs from 1 to n data set that you have, or m data set that you have. So for every data you will start predicting a value. So your h theta of x would be your predicted value, and y is your actual value, which is already labeled, right? So if you subtract these, what you will get? You get the difference, error. Okay, this is the deviation that I have my predicted value towards the actual value. So if you start minimizing this error, that means you are going towards the actual value. Okay, that is what is called the cost function. So these are the parameters that we do internally, or any algorithm will do internally, to attain the best accuracy or to make the model even better. Okay, so beyond this I will not go much in detail. Okay, but this is the high level explanation for you guys to understand what an algorithm does internally. Okay, this is all a math that does internally, it computes everything. Okay, so it has a cost function, it has got an hypothesis function, and then it predicts the attribute values or the hyperparameter, we call them as parameters as well. So okay, parameter values, and then it trains them in such a way that your predicted values are very close to the actual values. That is like you are minimizing the errors, and we actually measure that with some accuracy measures and all those things that we will see them. Okay, so by seeing the accuracy measures and those values, we can identify whether the model is performing in a better way or not. Okay, clear? Any questions at this point of time with the theory?
Yes, yes.
Okay, fine.
We
So
will take
now,
the questions in the last 10 minutes.
okay, fine. So okay, I'll not go too much into this math and all I said, like, but these gradient descents and all are the algorithms basically. As I said, right, you need to find this theta naught and theta one, which are the best suited values, right? So to learn theta naught and theta one, which are the best values of theta naught and theta one, we use some algorithm which is called gradient descent. Okay, maybe if at all time permits, we will go through these algorithms at some point of time, but this is how it goes. Just remember that it uses an algorithm called gradient descent to find the best suit values of theta naught and theta one. But now after knowing that, okay, this is all is happening internally, now where do you use this regression? Now I just wanted to show you this. See, now it somewhere it started the line here, and finally it was telling, okay, this is my best suit line. How did it do? Because it was starting theta naught theta one somewhere else, and then once it starts somewhere else, your line is something like this, and now the deviation between the actual points and the predicted points is way far away each other, right? So now it started iterating over it, and then finally it has found out that theta naught theta one are best values are here, and finally when it draws the line, it passes through this by minimizing the error between the actuals and predicted values. Okay, and now going through the classification, now this is what is regression, and I just wanted to emphasize where we use regression. Okay, now you know that there are two different algorithms, okay, regression and classification, majorly two categories of algorithms. But where do you use regression? So whenever you see a data set which has got continuous values, okay, example, you have a data set where you want to predict temperature. Temperatures are basically, your target is temperature. Okay, temperature is what? It's a continuous function, it's a continuous values, you will get it. Or you have a data set where you want to predict the height of a person, like based on their attributes. Height is again your target, and that is a continuous function. So whenever you are put into a problem where you find my target is a continuous valued functions, then that is where you just start blindly applying your regression algorithms. Okay, so most predominantly we use linear regression, or there are classes of linear regression like multiple linear regression, multi-valued linear regression, polynomial regression, all those things. So we use regression basically, so in order to get, but there is a catch here. So whenever people say regression, they just tend or blindly believe it is a continuous, but there is a special category of regression which is called logistic regression, where that is not used for continuous values, but in fact it is used for a classification of a binary valued data sets. In fact, that is, you are given a data set where I want to predict whether the person is prone to a cancer or not. Okay, that's like a two value binary classification, right? So it is like either 1 or 0, either he is infected or not infected. Those kind of problem statement, we use logistic regression. Okay, so always just remember, it is all dependent on the data set or the problem that you are tackling with. If you are tackling with a problem statement and you know that my target function is some continuous function, then just apply regression that is like regression of continuous regression algorithms. And if you know that you are dealing with a problem which is like a group, like it's a I can say categorical data, okay, categorical function, the target is a categorical values, then you should apply something called classification. Logistic regression comes under classification, but it is not the actual continuous regression. Okay, coming to classification, you have basic concepts, like what exactly it is, how the data looks like, what are attributes, all those things. But coming to different what do you say, algorithms, so you have decision tree. Okay, you have evaluation, I'm sorry, a rule induction, so you have different rules, and based on the rules you can classify. And one category of that is association rules, we call them as association rules. And then you have naive Bayes classification. I think like you all know Bayes theorem, right? So you have a probability of given versus probability of knowns, and then you have to calculate the probability of unknowns. So there you get the naive Bayes classification. And the power of this is you can actually apply to a corpus of text. Example, let's say I think like you all know there is a hot topic going in the world, that there is a war between Israel and Palestine. Okay, so now if you open Twitter and start collecting the data about this war, and then now you can apply this naive Bayes classifier there, and you can actually classify the text who are actually biased toward Israel, biased towards Palestine, and then who are neutral. So based on that you can know what is the population that are supporting Israel, what is the population that are supporting Palestine, who are neutral to this. These kind of insights you can draw. And at the same time we have something called support vector machine, where it will draw a clear cut separation boundary or a hyperplane in 3 dimension to segregate different categorical data. And we have something called k nearest neighbors, and we have ensemble methods. Ensemble methods are like, it's a hybrid methods in which like we study about bagging, boosting and all. Maybe I'll not be covering this, but just for your understanding, or just to tell you that there is these kind of a methods or algorithms are also available. I just kept this. And finally maybe we'll see summary if at all time permits. Now I'll tell you one realistic example. Okay, this is most of the times we even encounter in our own families also. Okay, assume that there is an emergency room, okay, which is like your ICU, MICU, SICU, medical ICUs and surgical ICU, MICU and SICUs. Okay, and then in a hospital, and they are measuring 17 different vital parameters of a human body, like blood pressure, age, respiratory, SpO2 levels, that is like your oxygen saturation limits, all those things. Now you are given a problem. You need to take a decision whether a newly coming patient should be kept under ICU or MICU or SICU or not. So now how you will do is, basically due to the high cost of ICUs, basically any ICU you take, it is very costly. Okay, those patients who may survive very less, okay, maybe like in my case I have taken the case study as less than a month, then those guys should be given a higher priority, because their lifespan is too less, because that's the whole point. Like I'll take them into an intensive care, and then I'll very focus on them. And then the problem is to predict the risk of the patient, and then discriminate them from a low risk versus a high risk. Okay, this is the problem statement that you need to tackle. Okay, now in this kind of problem statement, it is clearly evident that it is a categorical problem, because you are discriminating whether the patient is at a high risk or a low risk. Definitely we are going to use classification problem, and you will start applying different algorithms. Now how do you know? You can't tell, okay, I'll apply k nearest neighbors and I am done. No. Okay, you have to run with multiple algorithms, correlate them with the accuracies that they produce, and you have to fine tune hyperparameters such that you run the every algorithm again and again for multiple times, and finally you take a decision. Oh, okay, over the period of iterations, over the algorithms, over maybe like you done it for 5 different algorithms, over the 5 different algorithms, one of the algorithms is performing consistently good over all the iterations. That you will take it and finally you make it um, uh, production grade ready, and then finally you start using them for the realistic data that is coming from a client or a customer. Okay, it is not just okay you pick one algorithm and you are done. No, machine learning is not that way in reality or in practice. Okay, now since this is the problem statement, how I can do it? I can, as I said, like we have SVM, right? So I can say I can categorize those into two different groups, high risk versus a low risk, and I can draw one kind of a boundary or a hyperplane from a 3 dimension, saying that okay, I'll divide and then say okay, these candidates are like low risk candidates or a high risk candidates. Okay, and we call them as support vector margins, and these margins are close to the boundaries of actual data, and hyperplane is actually dividing those margins. And again, k nearest neighbors, so we take a new data point that is newly coming in patient, and then we actually match the attributes to already known data. So the attributes matching very near to the known data, so that means like that particular class he belongs to. That way you can actually get it. And then coming to decision trees, so maybe you will choose one root node, and then you will traverse in the tree. It is basically equivalent to your trees of algorithms. Okay, in the data structures and algorithms you might have studied, right? It is very similar to that, where you will take a root node. A root node, maybe you can take it as a patient X, and now you will start asking questions whether the patient X is of age greater than 80 or 90. I'm sorry, greater than 50 or greater than 80. Maybe you say greater than 50, you will traverse in that particular direction, and now again you ask one more question. So these are like you will traverse down the tree, and finally you will classify okay whether this patient is at a high risk or a low risk. Random forest basically is like a internally a cluster of decision trees only, but with a different permutation combinations, and out of this permutation combination it will take the best pick, choose or decision tree and give you the prediction over that. Coming to naive bayes, as I said, like you have a likelihood, you know the given probability and the evidence of probability, and finally you will say whether the given incoming patient, which is the new patient, is at a high risk or a low risk. Okay, this is a probability rule. So you can apply all these different kinds of algorithms, and you will run all these algorithms multiple times, and let's say your random forest is giving you much more good result. Finally we will pick one random forest as our final algorithm, and we will start putting it in front of our customer and directly serve the customer with the actual data. So that is how it goes on. I think so you have got a better idea, or at least a minimalistic idea, at what positions I have to use my classification algorithm and at what position I have to use my regression algorithm, and what are the different kinds of algorithm, variety of algorithms that are present under these two groups, like regression group and a classification group. Now what we will do is basically we will start coding it such that like you will better understand what exactly we are trying to do. Okay, so let me create a project. Okay, so I'm taking my Python interpreter. I have my env. Maybe I'll change my directory to desktop. Okay, and I'll say this as what do I do? Okay, I have two data sets. Maybe I'll explain about two data sets. One, I've done some research on the sleep disorderness. Okay, I've taken a lot of attributes, and finally we can predict whether the person is prone to a sleep disorder or not, because this is most evident in the young people or the young generation like you guys. Because as soon as you sleep, you don't sleep it, you catch your mobile phone and start YouTube, and that goes till 12:30 and 1 o'clock, and then you sleep it. Okay, so all the generation, the current generation, whether they are at risk of sleep disorder or not, that is one. And the other research that we are doing in close with the HR, whether the employee stays in the current job or he will quit based on some parameters. Okay, maybe we'll take one of these problem statement from a classification perspective, and we'll try to do it. Okay, so generic name for the project I'll give, I'll say classification problem or classification analysis. Okay, and on my desktop Python. Okay, create. Sorry, it came here. Okay, now it is. And now let me copy the data set here. Okay, what you want to do? You want to do sleep disorder or employee retention, which is like employee leaving an organization or no? That will be useful for a HR to how to pamper these employees as that he'll not go out of my company. Okay, so if you can, okay, maybe you will not respond or something like that. Okay, but I'll take my, I most of the time I love biology or biological sciences, so I'll take sleep disorder and then we'll start analyzing it. Okay, but similar way, I think like you can analyze the other data set also. Maybe I'll provide you that. Hold on, where is it? Okay, fine. So this is the data set. We'll see it in proper structure, that is like a CSV file, so you may not read it properly here. So I'll start coding my Jupyter notebook. So Jupyter notebooks could be coded in web also, but I'm using my IntelliJ, where I can use my Jupyter notebooks in IntelliJ also. I love this environment because I'm most habituated. But yes, normal Jupyter notebook, which you are already aware of it, that is almost the same thing. You will see it now. Okay, sleep disorder analysis. Okay, so okay, now let's go with a few of the import statements that are much needed for us. Okay, so this is used for plotting different data visualizations, because that is more important when you are doing machine learning. Your data wrangling and data visualization plays a very, very crucial role, because you have to understand the data before you jump onto ML. This is one more library which has got advanced plotting. Okay, so from sklearn dot model selection, as I said, right, the data would be split into two things. One is train data and test data. So we have a class called train test function. I'm sorry, not class, a function. Okay, train test split. So when you pass the data, whole data here, it'll, and you can tell like what is the ratio of your split. So it will split based on that ratio. It will split into train and test data. Okay, from sklearn dot pre-processing. So we have something called label encoders, and we have a lot of encoders actually. One hot encoder, label encoder. I've got simple. Okay, fine. Yeah. So label encoder and one hot. Okay, simple imputer. That is imputation. Okay, fine. Okay, so for now these are okay. So what I'll do is now I'll start. Reading the data. If you see it here, my Jupyter server has started and running here, and then these notebook will work right away here in this particular environment for me. And now let's start it. Pd.read CSV, and then we'll provide this CSV, and then this is the data frame that I'm collecting. Okay, just read it, and then we'll say df dot head, and then maybe 20 records would be a decent size. Okay, so now see it, this is the data that we have. We have person ID, gender, age, occupation, sleep duration, sleep quality, physical activity levels, stress levels, BMI, blood pressure, heart rate, number of steps that are being daily taken, and finally whether he is prone to a disorder or not. Okay, insomnia is gone case. Okay, so that means like he is like in a danger situation. Okay, this is the next level. And the other ones like which are nans are like unclassified. That means like there is no risk. If I'm not, I mean like I'm not a doctor basically, but at least like I see that these nans that doesn't have a data, maybe I can tell that these are not prone. Okay, so now what we'll do is this person ID is of not no use for us. Okay, we don't use it, or it is not useful or this data is basically not related to any of our actual attributes. ID is just ID, that's it. So maybe like we'll eliminate and then we'll check it again. Okay, so I'll say df dot drop. I have something called this, and then I have columns is equals to which column I have to drop. So we'll drop person ID, and then I'll collect it into the data frame again, the same data frame. Okay, execute. Now you don't have that person ID here. Okay, gone case. From a normal data set, we have eradicated but that particular column, which is like unwanted column for us. Okay, so now let's see like how many null values are there, something like that. Df dot is null dot sum. Okay, so which will tell like how many nulls are there for a given data set. Okay, so NaNs are not being considered as nulls, so but still we have to take out those NaNs and then give it a different thing. So what we will do is basically we will calculate the data set size before eradicating those rows and after eradicating those rows. Okay, so what we will do is we'll say print, and then we will say formatted string, and before uh, dropping the nan rows, it is df dot, there is a function called size, so entire data frame size you will get it. And very similar to that, I will print after dropping the nan rows, what is the size. So in between I will do that operation. Df is equals to df dot, we have something called drop na. Okay, now you see this what happened. So actually we have 4488 rows, out of which like after dropping I have lost almost many rows has been lost, like I got only 18660. Instead of dropping, maybe you can replace that values with some kind of a categorical value which is like unclassified or something like that. Okay, that also you can do it, but for better understanding I'm just removing it. Okay, and okay, so now what we will do is let's start doing data analytics. Okay, pre-processing or data analytics, we do it maybe like we'll do pre-processing. Okay, that means like if you see this BMI category, so for any machine learning algorithm, all the values should be in numerical format. Okay, you cannot have anything under categorical format. So obviously you have to convert that categorical or textual formats into the numerical format only. So that is where your encoders comes into picture, and that is the whole reason that I have imported them. So one hot encoder is a form where it will convert your column into number of rows. So that will actually increase the dimensionality of your data set. Okay, and the label encoder is just it will assign the one unique value for every category, and it will encode them into those particular numerical values. Okay, so for simplicity I'll start with the label encoder. Okay, and for one we will write it and the other ones we will copy. Okay, for gender there is male or female, if I'm not wrong, right? Yes, gender is equals to encoder dot fit transform. There is a function, so it will fit and then it will limit BMI. So it will telling this is the column that you have, so I'm just picking it. But you will not get this kind of intelligence in the normal Jupyter notebooks if you run it in your web. Sleep disorder, I think your blood pressure is also like 126 by 83. We don't need this kind of values, maybe like we have to convert this also. Okay, so same thing, so you have to copy paste. Okay, now if you just run this, okay, it ran, and then finally you say again head of 10, And now if you see this, see everything has been changed into numerical values. Nothing is actually a categorical now. Okay, so this is the beauty of encoders. Basically, if you do your one-hot encoding or label encoding, it is almost the same thing. You will find the dataset in the almost in the numerical format. Every value is converted into a numerical value, but there is a different procedure that is applied in the background. Maybe this session, if you go into every internal, it is not enough for us to learn all the things. Now from here I'll show you something, maybe like I have a code, I'll copy and paste and then I'll show you, because we are already approaching time. So if you see it here, so you have 50% of zeros and 50% of ones. This is like a balanced data set. So balanced data sets are actually good. If you have unbalanced data set, then again there is a headache, like how to make it more balanced in nature. Okay, so this is like, you can see the visualization. Okay, my sleeplessness prone data, and then normal people's data is almost balanced. Okay, and now if you want to see different kind of a distributions against your target value, example, if you say sleep disorder against my gender, that means like how many males are sleep disordered and how many females are sleep disordered. This is how you can get it. Okay, so these are like warnings. Okay, but we can eliminate these warnings, but yeah, this is how you can see it. So if you see this 0 and 1, maybe like male is assigned 1 or 0, I don't know, but this is that like two categories. So this is how the density of distribution against the sleep disorder is. Okay, and very similar to that, you can actually carry out different what do you say, data analysis. And one of the data analysis which is very much important for us is actually the correlation analysis. We just need to see what are the different attributes that are more correlated, such that we can eliminate them, we can make them as one. So assume that you have two parameters which are almost correlating, that means they are almost of same nature. So you can, instead of two, you can actually eliminate one and make one, eliminate one, and you can, instead of the two, like you can actually replace that by one. So by using that, what you are doing is you are reducing the dimensions. So you are making your data set compressed in nature. So for that, your correlation analysis is very, very, very important. Okay, see this. So what is here happening is, maybe I'll show you something which is like very good. So if you see, this is like 71% correlated, which is age versus sleep. Okay, so that means like you can, in fact, you can draw some inferences out of that. And if you see this sleep duration versus dense quality of sleep, okay, which is like 92% correlated. Okay, so you have to take now a quality decision, like which are to be taken out, which are to be kept back. So these are all like a discussion from a data scientist to a machine learning engineer, and then that will actually go forward. Now what I'll do is, maybe like I have one already created a date, a Python notebook. Maybe I'll get it here and then I'll execute and show, in the interest of time, because we only have 4 minutes left, I guess. Abid, am I right? Okay, so okay, maybe Abid, I don't know, I'm not hearing you, but yes.
Yeah,
So
yeah.
okay, fine. Now if you see that I have a lot of visuals drawn, I was been analyzing the target variable with the different what do you say, attributes of the data set, and finally I have correlation analysis, and then finally I split my data into two: train test and test set, out of the ratio called 20%. So my 80% of the data is training and 20% of the data is test set, and the shapes are something like this. And then now I have a pipeline created, so you can visually see this pipeline. So I have a column transformer, and you have a numerical data, and you have categorical data. I'm imputing them, and then you have a standard scaler, so we will scale them. At least example, why should we use scalars is basically, all your columns are of different values, varying from different lower end to a lower high, different high end. So I can't put a machine learning algorithm and such kind of a data. So your data should scale between either 0 to 1 or something else based on your lower and higher value. So that is where your scaling mechanisms comes into picture. Okay, we have a lot of scaling mechanisms. So I have used standard scaler, you have min max scaler and all, so you can use that also, you can trial that, those methods also. Okay, so once we are done with this, or once you form this particular pipeline, then I created some generic methods. So to prepare a model, I created this method to create the evaluation of that particular model. So I want to evaluate that particular model, so I created one method. So like that I have created it. Now maybe like what I'll do is I'll start running one by one, which is like very quick because it is already done. At the time of models, I'll start and I'll explain it again. Okay, pipeline is created, generic methods, execution. Okay, now the run start. Now what is happening is, now I said we can actually do it with multiple algorithms. So I am using bagging classifier, kn classifier, that is k nearest neighbor classifier, random forest classifier, ada boost, gradient boost, and I've been using the mlp as well, which is like a little perceptron, a kind of a neural network. You can think of a basic structure of a neural network, which is called multi-layer perceptron classifier, and I'm using XGBoost classifier. So these many algorithms I have run, and then I kept them, I stored them into my basic Python data structures like dictionaries and all, which algorithm is giving me what kind of accuracy and all. Now if I run this, so it ran, and if you print this, this is what is happening. My bagging classifier is giving 94.35%, knn is giving me 89, random forest on 95, ada boost on 95, gradient classifier on 95, mlp on 90, xgboost on 95. And to depict and understand how your classification is working, we use something called confusion matrix. This is the confusion matrix which will give us the true positive versus false negative or true negative values. So we can identify how many are in the right direction versus a wrong direction. So those can be measured using these metrics, which is like confusion matrix is one kind of a matrix where we can measure the accuracy levels of classification algorithms. But maybe like I'm on spot already, like to tell what exactly it is. Maybe tomorrow I'll take a little 5 minutes and then tell this. But today what we have done is we understood what is regression, what is classification, and then now you saw a run of a notebook. I think like it is pretty fast, but at least like you know how to load, and you saw some distribution live coding, but I've just bought then after. And then we saw how the model is built with the pipeline, and ultimately giving us different accuracy levels, and then we are measuring over some metrics called confusion matrix. And there is something called classification report also. If you come down, you can see that classification report, where you will see what is the accuracy, micro average, weighted average on different attributes called precision, recall, and F1 score. These are all different accuracy measures. So higher accuracy, higher recall and precisions that we will actually consider. So these all things out of the experience and practice you will get it. But this is the end to end an algorithm how you create. But this is not the end of life of a machine learning. But once you are designed a model, what you will do with this, you have to expose it to a customer, and you have to use it via APIs. Okay, you have to create a wrapper around this, and to that you send a new data, and it responds back with some kind of a prediction. How do you do that? That is our next tomorrow session. How do you create APIs around this? How do you deploy into a cloud? Excuse me, I'll take 1 more minute, that's it. So how do you deploy this into a cloud, and how do you expose those APIs to an end customer, and how he start accessing them? That is what is our next tomorrow's session. So once you are done with the model, it is about consumption of the model. We call it as how do you consume those models by giving you to a general public. That is our target of the next session that tomorrow we will be seeing it. With this, I will start my presentation, or basically a lecture delivery. It's all now given to you or over to you to ask questions, and I'm there for the next 15 minutes.
Yes, yes. So I'm just collected a few of the questions which we got from the participants. So first question I'm taking Chandrakumar Renuka. Difference between task T in logistic regression and classification? Question mark.
Okay, so I said logistic regression is also a part of classification only. So task T represents you are actually classifying it on some a desired objective function. If your objective is to now in this particular problem statement, that if you take my objective is to actually classify whether a given person is subjected to risk of insomnia or not. So that is the same T if you are speaking from a logistic regression or a normal classification.
Next question Usha. She is asking any other diabetic data set is there? Question mark.
Yeah, we do have a lot of diabetic datasets. Maybe if you are interested, I can point to some, but there are a repository like UCI machine learning repository and then Kaggle. You can actually search in them. I think like most recent datasets, if you prefer that, you will have more diabetic data. Yes, but definitely there is a diabetic datasets available and you can use them.
Sai Manikanta. He is asking, sir, resources for learning machine learning from scrap.
There are a lot of YouTube channels which actually teach you from scratch. So my suggestion is, yeah, you can actually go through them, but along with that, you should do a lot of homework. Okay, so you have to do a lot of practice, and your math you have to brush it a lot. And always it is good, if you're learning one algorithm, you also learn the math behind it simultaneously. That is where you actually master ML. If you don't want to master ML, just want to use the APIs, then I think like in the longer run it will not get sustained. But yes, as I said, there are a lot of YouTube channels. Maybe I'll post some YouTube channels, or Abid can also help you there.
Yes,
uh,
yes.
mm, uh, you can go through those channels and then get the knowledge out of them. Okay.
Renuga is asking, what is non-classified output?
Non-class Okay, non-classified okay, non-classified outpost is not known. Okay, it is something like a not known. Okay, you may be asking it from my current problem statement where I told NANs I can classify it as non-classified, because there are two different classifications already given for us, or two labels that are already given for us. One is the patient is already prone to insomnia, or there is a sleep illness or something like that, which is like a second category. But there are other categories which are like most of the data points are same. So there is no label associated. So I can replace those NANs saying that it is not classified. So there is no label or a classification attached to that data point or a data row. So that is what I meant by non-classification.
Yes. So most of the participants they are saying Vishnu Priya. She is saying excellent, nice session, sir. Uh, Radhika, she is saying informative session, sir. Dr. Jitendra Kumar, useful and informative session. Prahalad, excellent. Anusha, nice session, sir. And wonderful. Vijay, he is saying excellent session, sir. Aruna, it's a needful video. And one question from Vijay. What is the range of accuracy level to consider, sir?
Very tough question to answer, because it all depends on your criticality of the problem. If you are dealing with a problem of healthcare domain, example, let's say you are trying to predict a person who is prone to cancer or not, suddenly by mistakenly your algorithm gave 90% or 95% of accuracy saying that he is cancerous, then it is under risk. Okay, so he will get panicked. So if at all you are trying to deal with a problem which is like life critical, so if I am doing some kind of a predictive maintenance for my aircraft, which is about to leave into air in the next 5 minutes, okay, and it said like one of the engine may fail, Okay, so those kind of domains, right? The accuracy level should be 99.99 or something like that, or
Yeah.
at least like 99%.
Okay.
So but other ways, like you're doing it for your own internal purposes, or um, there are other problems, maybe like you I think like this is, I think like I heard Abid introducing you guys like from triple E or ECE, right? So assume that you are doing some kind of a machinery predictive maintenance kind of a problem, whereby analyzing some attributes of a machinery, you can tell them whether this machinery is going to come for a wear and tear in the next 2 months or 3 months. So that is not life critical. Maybe that time, maybe you can tell them 93% to 95% is a very good accuracy level. So it all depends on which scenario you are applying your machine learning. Hope I
Next.
answered your question.
Yes, yes. So Madhuri is she is asking, in order to learn machine learning, do we have to master the statistics?
Of course, statistics is actually the backbone. Statistics and probability, basically, these are like two different backbones of machine learning. And if you ask me, from ages, actually, we are doing these predictions and all, maybe in the manual way, but still the predictions are still there. How people used to do it, it is all basically dependent on statistics only. So yes, the answer is like rigid yes. Statistic would be a very helpful subject, and yeah, it is very good to learn as well.
And one more question from same Renuka. Is scaling is similar to normalization?
Yes, it is. So if you do a normalization, it comes to a common values, right? So very similar to that. If you scale, it comes to that normalization ranges. Correct.
Okay. So, and most of the questions I covered. One last question I will take from Madhuri. Sir, how important is statistics in ML? Already, I think so. It's answered.
It's answered. Yes.
Ah, yes. So, and last question I am taking from VJ. Sources to get data sets.
As I said, like you have a multiple data sets, like you have, even these days I'm seeing there is something called data.gov.in, where you can go, that Indian government data also you can get it. Some of the data is being made as public. You can do your analysis on those data sets as well. Predominantly your Kaggle is the best source where you can go ahead and get it. And there is something called the third one that I'm telling now is little old, which is called UCI machine learning repository. And there are other two sites also, which I'm not getting it right away into my brain, but these are the three predominant things that you can go. And another one is federal data dot federal dot in, or some not in .com, I think, which is like federal data sets. You will get it like from USA and all. These are the four things. There is one more I am not able to remember, but yeah, very good sources of information. You can go ahead, get it, use it for your thing. But data.gov and then data.federal, these actually you take your consent, that what are you trying to do with this particular data. Once you download, maybe like a research purpose or an educational purpose, they will allow you, otherwise they will restrict.
Yes. So it's and most of the answer means replies are wonderful sessions, sir. Thank you, sir. Thank you very much. Very useful video, etc. Now let us close this session with vote of thanks, sir. I take it privilege to propose vote of thanks, sir. I would like to thank to our today's resource person, Mr. M.K. Pawan Kumar, application architect and data scientist, Honeywell Technologies, for accepting our invitation and dedicating his valuable time with us. Thank you very much. And I thank all the participants for attending this workshop. So we will meet tomorrow at same time. Don't forget to submit the feedback, which will be which is already posted in the chat window. Submit the feedback for the purpose of attendance. So tomorrow at same time at 5:30, we will be meeting. Thank you very much.
Thank you, sir, and
Thank you.
have a nice day to everyone.
Thank
Bye.
you. Thank you. Bye.